This is my rocket, Pioneer, and you can make your own rocket like mine. Here's how. In Onshape, the CAD software that I used, I started off by creating a master sketch, turning the dimensions in OpenRocket into a template that I could use for the design. I created multiple different parts: a nose cone, body tube, fin can, and motor retainer. The problem I found was that, based on my dimensions, my 3D printer can't print the fin can and the body tube in one print, so I had to figure out a way to separate them and eventually join them back together for the launch. I decided to use threads to connect everything together, and this decision required a lot of testing. I had to create multiple test prints to figure out how to make my own threads. For the centering rings that centered the rocket motor within the fin can, I had to make them print at a 45-degree angle. This is because 3D printers can't usually print perpendicular surfaces without support material, and I didn't want to use that. At the bottom, I also designed threads for the motor retaining ring. This is to hold the rocket motor inside the rocket while it's in flight. I also had to do test prints to verify the tolerance for the rocket motor to make sure that it would fit inside, and also the launch lug that would allow the rocket to slide up the launch rail. For the body tube, I also used threads to connect that to the fin can, but otherwise it was a pretty simple design. For the nose cone, I had to do some testing to make sure that my printer could print the overhang that was required for the shock cord mount. Also, in the OpenRocket design, it calls for a 25-gram weight at the front of the rocket. I had originally decided to use 5 nickels, each weighing 5 grams each, to create that 25-gram weight in the front of the rocket and implant it into the nose cone halfway through the print. However, I had a lot of struggle with this, and I decided not to do that. When my dad suggested just increasing the amount of material inside the nose cone during printing, I realized that if I'd increase the infill inside the rocket, it would add 50 grams of weight. Finally, if you're interested in the full build process, check out the related video.